Okay, here's our next example. Remember that our goal form, our goal is to get our matrix in this form where we have ones along the principal diagonal, numbers everywhere else, and some column of constants. Then the easiest way for me to get a 1 where I want it in the first column is to swap rows 1 and 3. So row 1 swapped with row 3. Then I recopy row 2 as it is. And 3, 3, 1, 28. Alright, so now I have my 1s. I need to get my 0s in the first column. So the first thing I'm going to turn into a 0 is the 2. 2 times row 1, because that's where, negative 2, because that's the opposite of 2. Row 1 is where the 1 is, plus row 2, because that's where the 2 is. So we recopy row 1. And now negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 4 is negative 8, plus 9 is 1. Negative 2 times 2 is negative 4, plus 4 is 0. Negative 2 times 15 is negative 30, plus 38 is 8. And then I just recopy. I recopy row 3. So now I need to change this 3 into a 0. I'll do that by negative 3 times row 1 plus row 3, because that's where that 3 is, and store that in row 3. I will recopy the first 2 rows as they are, because they're not changing with this row operation. And negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times 4 is negative 12, plus 3 is negative 9. Negative 3 times 2 is negative 6, plus 1 is negative 5. Negative 3 times 15 is negative 45. Plus 28 is negative 17. All right, so now, and if you need a calculator on any of those steps, feel free to reach for your calculator. Notice that column 1 is perfect now. So let's move to column 2. I already have my 1 where I want it, which is nice, in column 2. So let's just focus on getting the zeros. So I want to change 4 into a 0. I'll do that by negative 4 times row 2. I'm using row 2 here because that's where the 1 is, plus row 1 because that's where the 4 is, and I store that in row 1. So now where there's a 0 in this position in row 2, that means this won't change because I'm just adding 0. Negative 4 times 1 is negative 4, plus 4 is 0. So negative 4 times 0 is 0, plus 2 is 2. So that didn't change. Negative 4 times 8 is negative 32. Negative 32 plus 15 is negative 17. And my other 2 rows don't change. All right, now I want to get rid of this negative 9. The opposite of negative 9 is positive 9. And when I say get rid of, I want to change it to a 0. So the opposite of negative 9 is positive 9 times row 2, because that's where the 1 is in that column, plus row 3, because that's where the negative 9 is, and it gets stored in row 3. So I will recopy the first 2 rows since they're not changing. And now that stays 0. 9 times 0 is 0, plus 0 is 0. 9 times 1 is 9, plus negative 9 is 0. 9 times 0 is 0, plus negative 5 stays negative 5. 9 times 8 is 72, plus negative 17. 72 minus 17 is is 55. Sorry, that took me a second. Okay. And now column 2 is also perfect. So finally I want to go to column 3 here. I want to change this negative 5 into a 1. I always want to get my 1 and then get my 0. So I'll focus on getting this to be a 1. I'll scoot my paper up. So the way that I'm going to change that to a 1 is to multiply by negative 1/5. Remember, you're not allowed to divide. If you want to accomplish division, multiply by the reciprocal of whatever you want to divide by. So I'm going to recopy the first 2 rows. And negative 1/5 times 0 is 0. There too. Negative 1/5 times 5 is positive 1. Negative 1/5 times 55 is negative 11. All right, so now I only have one number left. This 2 needs to be a 0. And so we will get that by taking negative 2 times row 3. I'm choosing row 3 because that's where the 1 is, plus row 1, and we store that in row 1. So this one is actually going to be pretty easy because all of these numbers here are really easy to multiply. Negative 2 times 0 is 0, so when I add 0, that doesn't change. Here too I had a 0, so that doesn't change. Negative 2 times 1 is negative 2, plus 2 is 0. And finally, negative 2 times negative 11 is positive 22, plus negative 17 is going to be positive 5. Then I can recopy the rest of my matrix. And that tells me that my solution is 5, 8, negative 11. So there is the solution to the system of equations that was represented by that matrix.